Somewhere in the silent darkness of the universe, a star is dying. It's been alive for millions, perhaps billions of years, quietly burning hydrogen into helium, keeping a delicate balance between the crushing weight of gravity and the outward pressure of its own nuclear fire. But that balance is breaking. In its final moments, the star trembles, its core collapses, and then an explosion so powerful erupts that it outshines an entire galaxy. For a brief moment, one single dying star is brighter than hundreds of billions of others combined. This is a supernova, a cosmic death that gives birth to everything you've ever known. Every atom of iron in your blood, every speck of gold in your jewelry, every molecule of calcium in your bones, all forged in the heart of a star that exploded long before our sun was even born. When we gaze at the night sky, we're not just looking at light. We're looking at the ghosts of ancient stars, the remnants of violent deaths that made life possible. But let's rewind for a moment, back to the beginning of this cosmic story. It starts with a star, massive and brilliant, far larger than our sun. For millions of years, it burns fiercely, fusing hydrogen into helium. When the hydrogen runs out, it begins to fuse heavier elements, carbon, oxygen, silicon, all the way up to iron. But iron is a dead end. Unlike other elements, fusing iron doesn't release energy, it consumes it. And when that happens, the star can no longer hold itself up. Gravity wins. The core collapses in a fraction of a second, crushing matter so tightly that protons and electrons merge into neutrons. Temperatures soar to unimaginable levels, billions of degrees. Then, like a cosmic recoil, the outer layers explode outward in a catastrophic blast. This is the supernova's final act, a moment of destruction so intense that it forges gold, uranium, and countless other heavy elements in the blink of an eye. But here's where it gets even more incredible. Out of this chaos, creation begins. The explosion scatters those newly forged elements across the galaxy, seeding clouds of gas and dust with the ingredients for new stars, planets, and eventually life itself. Our solar system, our planet, our very existence, all trace back to one of these titanic stellar deaths billions of years ago. Carl Sagan once said, "We are made of star stuff." It's not poetry, it's chemistry. Every atom heavier than hydrogen and helium came from a supernova, or its even rarer cousin, a neutron star collision. But supernovas don't just create elements, they shape galaxies. Their shockwaves trigger the birth of new stars, compressing nearby clouds of gas until gravity takes over and ignites new stellar nurseries. It's a cycle of death and rebirth on a galactic scale, and yet for all their beauty, supernovas are unpredictable, terrifying, and deeply mysterious. Imagine if Betelgeuse, the red supergiant in the constellation Orion, were to explode. Astronomers believe it could happen any day, or 100,000 years from now. When it does, it will shine so brightly that it could be visible even during the day, casting shadows at night. But don't worry, it's far enough away to be spectacular, not dangerous. Still, the idea that a single explosion could dominate our sky for weeks reminds us how fragile and dynamic the cosmos really is. But not all supernovas are the same. Some occur when massive stars die, collapsing under their own gravity. Others happen in binary systems, where a white dwarf steals matter from a companion star until it crosses a critical threshold and detonates in a blinding flash. Those are called Type Ia supernovas, and they're special. Their brightness is so consistent that astronomers use them as cosmic mile markers to measure the expansion of the universe. In fact, it was through studying these Type Ia supernovas that scientists discovered something astonishing in the late 1990s. The universe isn't just expanding, it's accelerating. Some unknown force, now called dark energy, is pushing galaxies apart faster and faster. All because we were watching the deaths of stars in distant galaxies, It's ironic, isn't it? The death of stars revealing the life story of the universe itself. Supernovas also leave behind strange, haunting remnants. Sometimes a dense, rapidly spinning neutron star, a pulsar, remains, beaming radiation like a cosmic lighthouse. Other times, the core collapses completely into a black hole, a region of space where gravity is so extreme that not even light can escape. In a way, every supernova is a fork in the cosmic road. One path leads to a pulsar, the other to a black hole. Both are fascinating, and both continue to shape the galaxy around them long after the explosion fades. Take the Crab Nebula, for instance. In the year 1054, Chinese astronomers recorded the sudden appearance of a guest star so bright it could be seen in daylight. What they saw was a supernova, 6,500 light-years away. Today we can still see its ghost, the Crab Nebula, expanding into space, glowing with the energy of the pulsar hidden at its center. That one moment in history connected ancient observers on Earth to the vast processes of the cosmos, showing us that even the heavens change. But perhaps the most mind-bending thought of all is this: supernovas might not just create the elements of life, they could create the very conditions for life itself. Some scientists believe that radiation from nearby supernovas can trigger mutations on planets, influencing evolution. Others suggest that the cosmic dust and shockwaves from distant explosions may even have delivered essential ingredients, like amino acids, to the early Earth. So the very forces that destroy stars might also spark the birth of living worlds. It's a paradox written into the fabric of the universe. Out of death, life. Out of chaos, creation. And in the end, when our own sun eventually dies, it won't explode like a supernova, but it will shed its outer layers and become a white dwarf. It too will return its material to the cosmos. That material may one day form new stars, new planets, maybe even new forms of life wondering where they came from. The story of the universe is the story of transformation. Nothing truly ends, it just changes form. So the next time you look up at the night sky, remember this: somewhere out there, a star has just exploded. Its light is traveling across the cosmos, carrying the ashes of creation, the raw ingredients of existence itself. And perhaps, billions of years from now, those same ashes will come together to form another world, another sky, and maybe even another being looking up and wondering, as we do now, where did it all begin? And the answer, whispered by the universe in the glow of dying stars, will always be the same. It began with a supernova.